Good morning, good afternoon, good evening to everyone. My name's Regis, and I'm a solutions engineer here at TigerGraph. Today, I'm going to talk to you about why it's a great idea to put graph analytics at the heart of your data operations. Just before I jump in, just one housekeeping item. Everyone's currently on mute. But as I go through the presentation, as you have any questions, please put them into the Q&A widget. I'll try to leave some time at the end of the presentation and we'll go through any questions there. And obviously, any questions that we don't get to go through, we will, of course, reply back to each and every single one of the questions. So if we get going, this is not going to be a tech-heavy presentation. However, I think it's important, as graph is still a fairly new area, just to level set everyone, give a sort of foundation level, a quick graph 101, and make sure we're all on the same page. So when we talk about graph and graph database and graph analytics, everyone's clear on what I'm talking about. And so if you look here on this slide, you can see, what I describe as an evolution in database prominence. So, we had relational technology that's been with us for a while now, very well understood, solves many problems, has some deficiencies, and those were exposed in a way with the advent of the web scale era. And we had NoSQL style technologies, typically with a key value style schema that answered some of those problems when it came to performance, when it came to scalability and high availability that was needed for this web applications and web scale. NoSQL technologies filled that gap. However, there's still certain deficiencies, especially when it comes to complex transactions, deep analytics, that relational technology doesn't solve. And this is where graph databases are coming now into prominence and filling that gap. And so if I compare graph technology to relational databases, which is still the most common type of database, I would liken it to if you were in your organization considering a new service or application and you were on a whiteboard talking with a colleague, mapping out the business or the entities within that business and how they relate to each other. And you could even use an example here. We have orders, how orders relate to products, how customers relate to orders or locations. You jump on the whiteboard and you'll easily be able to draw your entities and relationships, a typical entity relationship diagram, and how those different components are connected. But then when it comes to actually creating that application, what often happens is you need to tear down that model that's easily understood, very intuitive. Anyone could have just walked into that room on the whiteboard and understood how the data was related, what's going on. You tear that down so that you can shove it into a relational database. And now you're dealing in rows and columns. And when you need to then get the value out of the data and the insight, you then need to, at runtime, join that data. And everyone that's used relational databases will know that joining has a cost. It has a performance impact. Now, if you contrast that to graph technology, on the other hand, that same entity relationship diagram that you'd have drawn on the whiteboard, you could literally take that as is and create that schema in graph. And that's why you see there this, graph schema. That is actually how the database is represented. So you're moving away from rows and columns, and now you're dealing with entities and relationships and the direct connections between them. And this has two very powerful benefits, right? The first one is that it's highly visual. It's naturally how the brain reasons and picks out things in data. So suddenly you visualize your data in this way, things start popping out to you. You have insight into your data that you've never been able to have before. The second, let's say, performance impact, or the second benefit, let's say, of having graph technology is that you benefit from having the data in effect already connected and joined. So that performance impact that you'd typically suffer joining it at runtime in a relational database, think about it as the data's already connected. And so you don't need to pay the cost of the performance. So that being said, if we jump into, once you have a graph technology and you're using it, what are the sort of broad, let's say, categories of use case that you can support? And so there's three main areas. The first one is connecting data. How do I connect disparate sources of data? Because now I've got this system that effectively, when I'm loading the data, I've already done the joins, right? And so just one example here is United Health Group, one of the largest healthcare providers in the US, and they've got a Customer 360 application in which they've joined 200 different data sets. And they've got a particular screen that plots, let's say, the customer journey, where they've basically got 5 or 50 data sets joined, overlaid, presented on a screen for the first time in the company's history. And that's pulled together, all that data is pulled together in 50 milliseconds. The other broad area of usage is advanced analytics. And we're going to talk as part of this presentation around Jaguar Land Rover. And you can see there, in terms of their supply chain planning, they've gone from 3 weeks to 45 minutes. And as you could imagine, for a car manufacturer, that translates to tens of millions of dollars of savings. And then lastly, an area that really excites me is, once you have your data and you're loading it into a graph, you could now extract graph-based features out of that data that you weren't able to extract before. And you can feed those into existing AI and ML pipelines. And so Intuit are using an AI and ML pipeline for their fraud detection. So it's already in place, it was already working, but they put the data in TigerGraph and extracted over 118 graph-based features that you could only get once the data is in graph to basically enhance and augment their fraud ML and basically improve their detection rate. So these are just a summary of some of the examples of TigerGraph in production, transforming enterprises and getting value. So what makes TigerGraph different to other graph technologies? I suppose that's the key thing. What's different in TigerGraph? I'm not going to drill into the nitty-gritty of this slide. Like I said, it's not going to be a technical presentation, but I just want you to hold this slide in your mind, because I'm going to come back to it. But there's 3 broad features. This idea of deep link querying, 5 to 10 hops deep. You could think of this as joins, in a relational database, 3 or 4 joins, and you're struggling. More than that, you might not get your query back. Graph databases powered by TigerGraph really setting the standard here and leading the way, now catching up with NoSQL technologies in terms of scale. So now you could have a large scale graph. And in database analytics, the ability to do analytics in place, in database, without needing to move it around, and basically getting that extra insight into your data. And then last sort of tech slide, let's say, there's a query language underpinning all of this called GSQL. The idea is that it's very familiar to SQL users. So, everyone that's used to SQL could very quickly and easily pick up GSQL. It supports procedural type queries, conventional, let's say, flow. It's a Turing complete language, so you can code any logic inside GSQL, and it could be either a real-time transaction or an analytical transaction. So when you've got that sort of technology underpinning your business, you can effectively go to market with several different types of powerful use cases. And this is just a non-exhaustive list of all the different use cases that TigerGraph supports. We're going to talk today about supply chain and data ops, and actually they come under a broader umbrella really of use cases that we call digital twin. And it's a bit of a, let's say, a buzzword that is gaining prominence, and everyone's talking about digital twin at the moment. And so we're going to I'm just going to give a bit of an explanation of digital twin and why graph in particular is driving the reemergence of digital twin as a concept. So digital twin is not new. It's been around since the 60s, formalized by NASA. And the idea is that, you've got your real network of things. In this example, it's maybe components in a space shuttle or your space program. and you're going to create a virtual representation of that, or a digital version. And once you have your digital version, your digital twin, you can now start asking questions of that data that you couldn't ask before, right? So you can simulate things, you can check dependencies, and basically you could use information gained in the digital world to inform and feed back to things that you do in the real world. And the reason why it's become, let's say, such a big thing, and there's such a tight synergy with Graph, is because Graph is really powering the sort of modern digital twins. If you really want to get the most of creating a digital twin, the best thing to do is really to put it into a graph, because you can do this deep link querying. This is exactly the sort of thing that you do when you've got this network of data. You want to understand dependency chains. You want to understand how different components interact with each other and the knock-on effects. And if you can do what is effectively 11 hops, so you could think of this as joins, and you probably couldn't even do 11 joins of large tables in a relational database. But if you can do that in real time, so 100 milliseconds, as you've got a system that's, you know, ingesting data and serving 2,000 queries per second, then this is exactly the type of technology you need underneath you to power a real-time digital twin. We all know data is exploding. It's only going to keep going. TigerGraph is well into the tens of terabytes of data and going beyond that. And then also, if I want to do a full graph analytics, you know, I want to look at the whole network, not just one component, you have a system in place that can effectively do analytics over tens of billions of vertices and edges. So if we move then to data ops, and specifically why, you know, data ops is a good example of a digital twin. You know, data ops is primarily around or about the flow of data through an organization, whether that's sort of source data that's coming in, ETL jobs, moving data from one table to another, you know, concerning yourselves with the columns that comprise given tables, the reports that are at the end of the process. And we can use an example from a large retailer that created a digital twin of their data operations. And this is just a little graphic here of the sort of complexity that you can imagine. So you've got all these tables, you've got flows of data moving right the way from production to logistics to sales. You've got the orange arrows that, you know, represent some sort of ETL process. But once you've created your digital twin of your data ops, you can start asking these sorts of questions around the lineage. So data lineage, dependency chain. If I've got a problem, how could I perform rapid root cause analysis? All this is possible once you put your data into TigerGraph as a digital twin. So in terms of the actual business problems and the value received by this large retailer, these are the three key problems, let's say, that were solved by this solution. Fault finding. So if there's a data fault, what is a complete lineage? How can I basically trace back up upstream to understand all the components that have to come together for me to get this report, so I can understand what might be broken? There's schema change management. So if I have a problem, you know, with the data, if I'm thinking that I want to make a change to the schema, what are all the other data elements downstream that might be impacted? And then ultimately, I would say, let's say the biggie or the big one is, if there's a job that fails, what are all the other jobs that are at risk? Who are and who are the stakeholders for those jobs, so that we can let them know ahead of time and they could do something to mitigate that. And so I'm going to walk you through just a very quick real world example. You know, what does that really mean? Or what did this really mean to this retailer? And so this is an example of the sort of issue handling where there's an inventory error. And so we have, you know, a shipment of tea bags that have arrived. The depot manager or the distribution warehouse manager comes in and sees that there's a notification to say that the stocks are low. He would then need to call his colleague to try and understand if she's experiencing the same issue. On her behalf, she hasn't necessarily, but she's got a message from her team to say, you know, it's already been packed, but she thinks there might be some issue with the inventory system. So then Mark needs to call the scanning team, understand whether they've arrived. then needs to call the inventory system operator to understand what's wrong, and then needs to speak to IT. So all this is effectively time consuming, and it's stopping potential fulfillment of orders. With TigerGraph, really all of that is essentially cut out. Mark might come in the morning and see that notification to say that stocks are low, but he'd also see a notification from the TigerGraph application basically saying that there's been a fault with the data propagation. Once he goes into the application with a few clicks, he could easily see where the problem is, and even a status and update saying that the IT team are already working on the issue. And so what this effectively means is that without TigerGraph, a lot of time is being consumed, several hours, and a potential of reduced sales. With TigerGraph application, really, this is now 5 minutes to resolve the problem and to understand what's going on. And so what I'm going to very quickly do is just showcase, what that means, what the app would look like. And this is just let's say a contrived demo with, demo data, but it's just to illustrate the principle here. And so in this example, I've got a problem with my, let's say, process that's supposed to update the inventory process. And so if I look at this, this vertex or this entity, and I can effectively say, what are all the downstream dependencies? What's all the knock-on impact? Or you could call this blast radius. What's the blast radius of this issue and this problem? So now I can see all the components downstream. I can effectively then email all of those stakeholders like Mark to let them know that there's a problem and they could do something about it. In terms of some of the other questions, I could also say, if I've got a report and there's a problem, I want to be able to look upstream. I want to be able to look and say, okay, well, what are all the components, or what's changed, what's happened, why maybe my report's not working? And I could basically look upstream. So this is a very sort of simple example. With proper production data for data ops, this is a lot more complicated, but hopefully that gives an impression, an idea of the sort of application and what it would look like. Okay. So, you've seen you could link and visualize and model all the data, all the dependencies. Users have individual access to the application. Very quickly, they can understand what's gone wrong, who to inform, and what else might be at risk of breaking. Due to the fact that, a large scale, very scalable, high performance graph technology is underpinning such an application, it means that it could be into the hundreds of thousands of different data components that could be modeled. And effectively, Graph is able to find that needle in the haystack for you. And then as I mentioned, whether you have, hundreds of thousands, millions of different components, you can model that very quickly in Graph, keep ultimately your data ops digital twin up to date in real time, because a digital twin is only as good as it being a reflection of what's happening in real time. And that's what you can do with TigerGraph. Okay, so then if we quickly move on to supply chain optimization and how Graph helps in this area as well. So we know from the research that there is a distinct issue when it comes to lack of visibility in the supply chain. And so you can see here, whether it's lack of the complete visibility of the supply chain, whether it's lack of ability to be proactive in response to changes, these are very real issues that companies are facing. And if we go back to one of the examples I spoke about earlier when I was talking about Graph and its ability to connect data, TigerGraph is a great way, a great tool that enables you to basically connect various components, whether that's your supplier data, could be your car data, right the way up to the actual end customer and their car. You could effectively model this and map this in TigerGraph, connect this data for the first time and gain value and insight from the data. And this is effectively what Jaguar Land Rover, what they did, right? They were experiencing huge fines from the suppliers, ultimately because they weren't able to do analysis in a timely manner when there were changes, when there was a change in their forecast, they couldn't update their suppliers in real time or quick enough. And so what they needed to do was take data from several tables and several systems and join them. And that was right away, like I said, from customers, vehicles, features, parts, suppliers, so that once they put that data in TigerGraph, they can now start doing advanced production planning. So predictive analytics, real-time simulations, and scenario modeling. These were all the things that they were able to do. And I'll, in a few slides, I'll show you exactly how they were able to do that. But the ultimate business benefits were that they saved themselves from all these fines that literally run into the millions. And they were just able to be a much more agile and nimble organization that could respond in real time to changes in demand. And if you look at the two sort of quotes here, I think they're quite powerful quotes, really. And that's, once the data's in graph, they could now model things that would previously have taken days in literally minutes. And so that goes back to the sort of performance element that I spoke about at the top of the presentation. And then I really like the second comment here, which is basically, they can now ask questions of the data that they weren't ever able to ask before. And some of those questions could be questions that from a performance perspective with the relational technology, they just couldn't get an answer back. But some of the questions could literally be just things they couldn't ask before because the data weren't in graph. So now they've just got new ideas. And so this is quite powerful, quite transformational, the level of innovation that JLR have achieved by using TigerGraph. And so just to give you a flavor of, okay, so what did they actually do? What does it sort of look like? Effectively, they created a multi-dimensional graph. And in that graph, they have their suppliers and how they're connected. And ultimately, those suppliers provide parts. Those parts come together to create features. And then those features ultimately come together to create cars. And so once they've created this, let's say, digital twin, right the way from their suppliers to the actual cars themselves, they can start asking some really interesting questions of the data. And so one of the questions that they wanted to basically ask was, what's our supplier risk? If there's demand that's surging for a particular model, how can I make sure that we're going to have all the parts to meet that particular demand? And so if you look here, you've got these particular patterns. If you look here, this sort of pink color, this is a pattern that you would see when you have a part that is basically, or let's say a supplier that is supplying too many parts. So you're dependent on all of these parts on one particular supplier, which is not a good situation to be in. And so now once you have that information, you can effectively look for potential alternatives. And in the yellow, we're basically saying in this example, well, there's only one supplier for this part. Now you can go and find potential alternatives. And these things will reduce supplier risk. The second way that they use this data is basically to see how they can make better use of inventory. So if something, let's say a particular model has slowed down, and so they don't need to make so many of that particular model, what can they do with the parts that are now in surplus? What parts can be used for other cars? And so now you could use the graph to effectively start at, let's say, Discovery Sport, go down the chain to look at the parts that it has in common with another model, right? And so now you can see that you can make better use of inventory when you know how connected these models are actually connected in terms of the parts, the common parts that they have. And then lastly, you've got what we call an optimization problem. And this is really quite sophisticated scenario modeling, really, and an optimization problem where what if we change very slight sort of what ifs? So if I just change for a particular model of car, maybe instead of an Evoque with a plain roof, what if I use or create an Evoque with a sunroof? What would be the revenue impact and what would be the cost impact? And if I make hundreds of thousands or millions of these slight changes, rerun my model and get my data, I could understand what is the optimal car, basically in terms of the features and parts that comprise that car. So this is very powerful capability that's really leaning on the core capabilities really of technology like TigerGraph. If you can do very performantly these slight changes and recalculate, then it will help you find the most optimal solution. So in terms of the actual benefits that this has helped JLR achieve, we sort of spoke about at the top, the sort of headline, going from 3 weeks to 45 minutes, that translates to tens of millions of dollars, especially right in the middle of COVID. In terms of, certain KPIs, in terms of the value, 120 times faster decision making, right? This is a key KPI. Supplier risk, 35% lower. And I showcased, how that's sort of done when you've got this multi-dimensional graph, and then just ultimately 3 times more business value than compared to their relational backed system. So I highly suggest to check out this Gartner report. It obviously has a whole lot more information than what I was able to go over and show today. So just to quickly wrap up, how do you get started with TigerGraph if you want to test out this powerful transformational platform? We have a cloud product available on all the major clouds, and you can get going with just a few clicks. There's a sort of starter, 50 gigabyte free database, and it comes with what we call these starter packs, where you can get data. You can get a schema, pre-built data, pre-built queries. So you can, just get an immediate impression of just how powerful this technology is. Okay, let me just have a quick look at questions. Anything? No. Okay, there we go. Let's have a look. How does it differ from relational databases? One specific table. Yeah, so you would have, it's fairly similar. It's fairly similar to a relational database, in that the way that you would have, let's say, a company's table, and then you've got rows of companies in that table, you would have a company's entity type, or what we call a vertex. And then you'd have instances of that company vertex or entity. So it's very similar, and you could have attributes the same way that you'd have columns in a relational table. You would have attributes in your graph vertex. So you'd have an instance type of a particular company, and it would be a vertex. And you saw an example of that circle that represented a particular entity, and within that you could have attributes just like a normal table. How does TigerGraph integrate with common ERP systems? Typically we support basic sort of ODBC or JDBC style connections. So many existing applications allow you to open up a connection via ODBC or JDBC. So we support that. We support common, other common formats like, putting data into a, extracting data from those systems in the form of CSV or JSON or Parquet, and placing it into a loading area and simply just loading that data up into TigerGraph. And we also have a Spark connector, which means that you can point Spark at those systems, do the simple translations, and then load the data into TigerGraph. Okay, I think we're bang on time. Thank you very much for your time.